In this video, I'm going to teach you how to implement a naive Bayes classifier with Excel. Now, if you're not familiar, naive Bayes is an extremely common data mining technique. It is a predictive modeling technique. It is actually a machine learning technique. And yes, you can implement this useful and powerful technique in Excel. Nothing fancy. No VBA code, no DAX code, just using simple tables of data and common Excel functions. Naive Bayes is a quintessential algorithm used in the spam filtering space. So a naive Bayes classifier is often used for evaluating emails as they come into somebody's inbox to say, hey, is this email ham, that is a legit email, or spam? This is an illegitimate piece of email. Now, in the modern age, we've gone beyond email. We've gone to SMS text messages on our phone. And guess what? Spammers now send text messages to people trying to get them to buy things. I don't know about you, but I get this on my phone all the time. I get messages where I'm like, where did that come from? They're trying to sell me something. That's spam. So what we're going to look at in this particular video is how you can use trusty old Excel to build a naive Bayes classifier to evaluate whether or not SMS text messages are ham, that is legitimate, or spam, illegitimate. This is what's known as classification. And in the predictive modeling and the machine learning space, classification is an area of predictive models that allows you to predict a label. Ham, spam, approve, deny, should a customer be silver, bronze, gold, platinum, diamond, black, I don't know, right? All these different kinds of labels. We're not trying to predict a number. We're not trying to predict something like sales or height or weight. We're trying to predict a category. That's what's known as classification, which is an extremely common data mining scenario in the business world. And the great news is that you can use trusty old Excel to implement a naive Bayes classifier super simply. And let me go ahead and flip over to Excel and show you how to do it. So here I am in the Excel workbook for this particular video. If you're interested in getting the file, you can go ahead and find the link to the GitHub down below this video in the description. Click it, you can download the file, and you can use it to follow along in this video. So here's the first thing. When we're going to train a classifier, and it doesn't matter whether it's naive Bayes or a decision tree or a neural network, doesn't matter. The thing that you need to most fundamentally understand is the data that you use to build the classifier or to train it is essentially the universe as far as the classifier is concerned. It only uses the data it has. That's all it knows. So for example, this data right here, and there's more than 1,000 rows of data in this particular table of data, is a subset of an actual real world data set of SMS text messages and whether or not they are ham or spam, whether they are legitimate or not legitimate. There'll be a link to this data set below the video in the description, of course, so you can go check it out. But as far as this naive Bayes classifier is concerned, this table of data right here is the universe. It's all it knows about SMS text messages in terms of whether or not they are ham or spam and what actually constitutes an individual SMS text message. So for example, we can take this table of data and I can pivot this data to illustrate, for example, what the naive Bayes classifier learns from this universe of data in this table. And what it learns is that out of the 1,114 rows of data in this table over here, the universe of data, approximately 86.62% are ham or legitimate SMS text messages and 13.38% are spam or illegitimate SMS text messages. So this table gives us the first piece of information for the naive Bayes classifier. It has learned this. And what it's learned is, generally speaking, if I know anything else about the SMS text message, I'm going to assume about 87% of the time that it's legitimate. So for example, a really, really base level classifier will just classify everything as ham because based on the universe of data, it would be right about 87% of the time. And that's pretty good. However, we can do more than this. And that's where the other columns come into play. So first up, what we have here in column A of this table is the label. So each row in this table represents a single SMS text message. And this label tells you whether or not it is ham or spam. Cool. And that is the thing that the naive Bayes classifier needs first and foremost to learn from the data. Now, I'm air quoting learn from the data because, as you will see in this workbook, I've set it up for maximum educational purposes. It's not necessarily the most efficient way to set up an Excel workbook to do naive Bayes classification, but what it shows you is the steps that you do as the analyst with Excel to make the naive Bayes classifier learn from the data. So that's why I'm air quoting it, and I'll try and stop that because that's kind of annoying. Okay. What are these other columns then? So what we just said was that, look, at the first thing that the naive Bayes classifier learns is that all things being equal, based on this universe of data, 87% of SMS text messages are ham. They're legitimate. But we could do better than that by understanding what's actually inside the SMS message and then use that as part of the naive Bayes classifier's learning. What this represents here are the actual words, the actual tokens, the actual little nuggets of text inside the SMS messages. So for example, this column represents the word TXT inside of an SMS message. This column represents the word mobile inside of an SMS text message. Can, get, love, home. You get the idea. Now, this representation here is not the complete data set. So if you actually go to that link that's in the description below the video and take a look at the actual data set, what you will find is if you set up the data this way, there are more than 3,000 individual columns of data, because in the entire data set, there are 3,000 individual words being used at least once in one of the text messages in the full data set. But to keep this tutorial tractable, I have artificially narrowed it down, one, to a subset of the rows of data. We only have 1,100 rows of data, and there's many, many more than that in the official data set. And then also these 10 columns of data. And like I said, there are actually more than 3,000 columns of data when you represent the data this way. So this approach of having a column of data for each one of the individual words, which are known as tokens, the individual tokens in the text message, is what's known as a bag of words model. Because what this tells you is that the actual language itself is being ignored by the naive Bayes classifier. That's one of the ways, by the way, it's naive. It doesn't understand, for example, that you can do this and can you do this are actually two very different pieces of information. But think about it this way. Can you do this? That'd be 4 columns of information would have the same columns as you can do this. Although we know as English speakers, those two sentences are completely different. This representation, they would look exactly the same. They would have those 4 columns of data in each row, because there'd be 2 separate messages, right? Would look exactly the same. They'd have ones in all the columns because that word is present. So that's what this means. So for example, this row right here was delineated as spam. It has a label of spam. And it had inside the text message the word call 1 time, and the word free 2 times, the word mobile 2 times, and the word you once. So this is the representation of this particular SMS message and the individual words in the bag of words model and the frequencies that they showed up. So we can now use these columns of information to augment this base learning that the naive Bayes classifier first learns, which is about 87% of all SMS text messages in my universe of data are ham as opposed to spam. And by the way, technically these percentages right here are what is known in the naive Bayes classifier as the priors, or the prior probabilities. How many labels you've got up, count them up, and what percentage of it is. And then the naive Bayes classifier says, if I don't know anything else about what's going on in the data, I know 87% of the time, approximately, that it is a ham SMS text message. Okay, cool. Next up, we need to say, we have this particular piece of information, and we want to use these columns, these additional 10 columns here, to improve the amount of learning that the naive Bayes classifier has done so that it can create more accurate predictions. Next up, we need to say, let's go look at the ham messages by themselves. So what we do is we just go to the ham worksheet here. And what you can see is the table of data now, the universe of data right now, if you want to use that terminology, for this particular worksheet is only the 87% of that original table that are labeled ham, labeled legitimate messages. And you can see over here that the chance of ham, that's the percentage, right? What we saw earlier, our prior, translates into a decimal of 0.8 662. And we can see that there are 965 rows of data that are ham in the original data set. Now, if we're going to use these other 10 columns of information in our naive Bayes classifier, we actually have to do some math on them. We need to understand what's going on inside of the individual ham messages from a word count perspective. So what you can see here is the first thing that I do is I create a table of token counts, or the count of the words, right? Token and word, same thing. And you can see here, out of all 965 rows of ham SMS messages, we have only one incident, only one token, only one word of TXT out of all 965. Next up, we have the word, the token call. It shows up 53 times in total. And you've got the sum of the word you here, for example, and it shows up 196 times. Now notice this. This is the absolute count of how many times this token, this word, shows up in all of the messages. So if a message has the word you, just the letter U as a word, twice in the SMS message, it's counted twice, right? Because it shows up 2 times, and there are 2 incidences of that word, of that token, across all 965 messages. This is important, right? This is not the count of messages where you shows up. This is the count of how many times you shows up in all of the messages. Okay. And then down here at the very bottom, you can see here, in this table of data, in the universe that is our ham messages, we have 465 total words. You just add these all up and you get 465. This is how we're going to use this text information, this bag of words model, to increase the learning of the naive Bayes classifier. So hopefully it's more accurate in discerning, in labeling, and predicting whether a new SMS text message is in fact ham or spam. Next up, we calculate the percentage chance, also known as the probability or the likelihood of an individual word or token showing up in the ham messages based on this table of counts here. Text. What is the percentage chance of seeing text in a ham message given this universe of data? Because that's all the classifier knows is what the data we provided. So this is all the data it has in time and space. So I can just click on this and show you the formula. And you can see here it's actually pretty easy. You can see it's 1 plus 07. So if I just click on that, you can see it's 1 plus this value divided by the number of word counts. And you might be wondering, why is it 1 plus the count, Dave? You said text only shows up once, but you're adding 1 to it. Now it's 2. Why is that? Great question. So let's go ahead and take a look at claim down here. The word claim, the token claim, shows up 0 times in the 965 ham SMS text messages, at least as embodied by this table, this universe of data. We'll see later on that that's a problem, because anytime you have a 0, what it's going to do is it's just going to zero everything out. Because what we're going to do is we're going to multiply a bunch of these numbers together. And anytime you got a 0 in there, it just cancels everything out, right? Because 0 times anything is just 0. So you want to avoid having zeros in your naive Bayes classifier in this particular case. And the easiest way to take care of that is you just add 1 to everything. So nothing becomes a 0. So for example, if I click over here and look at the formula, you can see here, oh yeah, if I add 1 to 0, I get rid of that problem. I artificially raise up the calculation by 1, but since I do it everywhere in all the data, as we'll see, both in the ham messages and in the spam messages, it all just kind of evens out and it gets rid of that 0 multiplication problem. So that's really important. So what we can see here, for example, is what is the percentage chance that you're going to see the token of claim in a ham message? And you can see here, it's really, really small. It's less than 1%. It's actually 0.21%. Because what this tells you is, this table right here tells you the conditional probability. It's a very complicated term. The conditional probability for each one of these word tokens. Easiest way to think about it is, hey, if I got a ham message, what is the percentage chance that I'm going to see free in a ham message? And it says it's about 3% based on this universe of data. That's what's known also as the conditional probability, or more formally, what you would say is the probability of seeing the token free, given that we have a ham message, is 3%. So we've now got all of our probabilities, all of our likelihoods, all of our percentage chance of seeing the individual tokens in ham messages. Next up, all we need to do is replicate this process for just the spam messages. And what we can see here is the worksheet. I've just clicked on it, the spam worksheet. And you'll notice if I go back, the numbers change. So we have our spam universe of data right here. And we can see that there are 149 of them in total. Oh, that should say spam. I'll fix that. And the percentage chance of a message being spam, which is around 13.38%. And once again, we go through and we count up all the tokens for the spam texts. And we can see here is, oh yeah, these words seem to be a lot more common in spam texts than they are in ham texts. And then we add them all up and get 261. And notice once again, we have home shows up 0 times in spam texts. So once again, we want to use that 1+ trick to avoid that 0 multiplication problem. And what you can see here are the conditional probabilities, the conditional likelihoods, the conditional percentage chances of seeing a particular token, a particular word in a spam SMS text message in our data. This is the process, right? It's manual. You're doing this in Excel yourself. You are learning the naive Bayes classifier model through each of these worksheets. We start with the priors at the very first worksheet, and then we create the conditional probabilities, the conditional chances of seeing individual words based on whether or not it's a ham SMS text or a spam SMS text. So we're learning. I know you're probably thinking to yourself, geez, Dave, when are we actually going to make some predictions? We're almost there. This is all of the learning that needs to be done. And we put this all together, and we're then able to create predictions when we head over to the predictions worksheet. So let me scroll up here real quick for you. I just want to show you that on this worksheet, we have the table of conditional probabilities, the conditional likelihoods for the ham messages here, and for the spam messages here. Notice that they're exactly the same collection of word tokens and just the relative percentages based on whether you're ham or spam. That's just lookup. We're just using that as a lookup table, as you'll see later. If I scroll down, what you can see here is the actual process of using the information that we learned on the previous worksheets to actually create predictions. So let me show you what I mean by that. So if we have these hypothetical new raw text messages, okay, these are brand new text messages. These weren't in the original universe that we saw before. So we've used the data to create a naive Bayes classifier, and now we want to use it to predict whether new text messages coming in are ham or spam. This is how we do it. So first up, we have to break these guys down into the bag of words model. And you can see that right here, right? You can map, for example, you call mobile, you can get home. And you can see here, 0 text, 1 call, 0 free, 0 claim, 1 mobile, 2 you, 1 can, 1 get, 0 love, 1 home. Makes sense, right? We just take this and we just break it into that. Now, this is the other aspect of where naive Bayes is naive. First up, it ignores word positioning. And consequently, what it really does behind the scenes is it says, look, because I ignore the English language, I ignore how words actually are used in the English language logically, I can then say the occurrence of any particular word in an SMS text message is independent of any other word. And that's just a fancy way of saying like there's no relationship between can and get. It could be can and get, it could be get can, I don't care. That's what naive Bayes says. That's why it's naive, because it's saying, look, everything that I see, I'm going to assume is totally independent. And the great thing is that even though we know as people who speak English that that's totally silly, that's not how it really works, there are actually word associations. That naivete works well. That's why naive Bayes is often a go-to algorithm for spam filters, whether it's in text messages or email messages. And we've got our naive representations of these individual text messages in this table of data right here. And now you can see the predictions. But the question is, how did we come up with that this is a ham message and this is a spam message? And that's where these tables over to the right come into play. Let me go ahead and scroll over for you. So what we need to do is we need to score the individual messages. Now these numbers correspond to the message directly to the left. Everything lines up. So the first thing is we start with the prior. And what we know from the original universe of data, what we learned from the original universe of data, is that 86.62% of the time, a message is ham. It's legit. So we start with that because we say, look, if we don't know anything about what's going on inside the text, at least we know that from our universe of data, almost 87% of the time, an SMS text message is legit. And the next step, what we do is we say, okay, what is the actual presence of the individual words in the text message? And let me scroll back over so we can see this a little bit more clearly. So in this message right here, right, this first message, we know that we have one incident of the TXT, the text word token. So what we do is we say, okay, great, go over here and look up the value. So if I just click in here real quick so you can see it, you can see that this particular cell's formula, is using this piece of information, how many incidences of this word token were there, and I'm going to go look up what the conditional probability is. So for example, if this message is ham and this text thing is in there, what's the percentage chance of me seeing it? And what we can see is it's 0.0043 approximately, and sure enough, that's what we get. So we're scoring this particular representation in terms of its hamness, if you will. We'll also score this particular representation in terms of its spamness. Then we'll compare them to say which of these scores of hamness versus spamness is higher, and we pick the one that's higher. That's how we come up with the final prediction. So what we can see here is that there are no call word tokens in this particular text message. And so we take anything raised up to the 0 power. Let me explain this real quick. So I've clicked on this cell and you can see up here that I'm actually using the power function. And the reason for that is when we have more than one incidence of a token. So for example, later on, we'll take a look at a text message that has the token U, just the letter U, in it twice. So that's why we use the power function, because what we want to do is we want to take its conditional probability and use it twice because that U is in the text message twice. So what you do is you take the probability of seeing one U times the probability of seeing another U and multiply them together. Well, that's just the probability of U squared. And that'll make more sense in a second. So just bear with me on that, okay? So right now we say, look, anytime we have a 0 in one of these tokens, what we're going to get out of that by using the power function is a 1, because anything raised to the 0 power is 1. And notice that that's okay, right? Because using a 1 doesn't change the final calculation. 1 times anything is just the thing that you originally started with. So 1 just is kind of like a pass-through. It doesn't affect the calculation. So you can see here that we have 1 free, and we have 1 mobile, and we have 1 can, and we have 1 love. And let me scroll over a little bit, and we have 0 home. And what we do is we say, okay, cool. Once I've got all of these values, I just multiply them all together. So I multiply this times this, 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 so on and so forth. So if I go over here to the score, what you can see is it's just the product, right? I just use the product function, and it just multiplies all those individual numbers together. And as I said earlier, that's why it's okay when we have a calculation of just 1 for an absence of a particular word token, because 1 times anything is just the original thing, and everything's great. So what you can see here is that our value, our score of hamness for this particular text message is really, really small. It is 7.099 to e to the negative 9th. And if you're not familiar with scientific notation, what you do is you take that decimal point and you move it 9 places to the left. So it becomes 0.000070999 and then some other stuff. So it's a really, really small number. And that is the calculation of the hamness of this particular text. Like I said, I'll explain the power stuff in a little bit more detail with the next sample message. So let's go ahead and scroll over here and let's look at the spamness of this one first text message. And what you can see here is the spamness. And we start with the prior. We can go through, we can do all the calculations here, right? Text was present, call wasn't. Free was present, claim wasn't. Mobile was present, you wasn't, so on and so forth. And then eventually you get to a score. Once again, notice that it's the same idea. You just calculate the product of all of these numbers, multiply them all together across the board, and you get the final scoring of the spamness of this text message. And it is 8.81 to the negative eighth. Now, without even looking at it, you can see here that negative 8 is a smaller number than e to the negative 9, which means that there's less zeros after the decimal place here than there are here, which means that this number is larger. And then what that tells you is that this is a spam message because the spamness score is higher than the hamness score. Now let's go ahead and take a look at this last message here. You call mobile, you can get home. And notice that the word you, the word token you, is in here twice, as you can see right here. This is where the power comes in. This is why we're using the power function. Because what we want here in this particular calculation of the hamness of this message is you was in there twice. So what we need to do is look up, I'll scroll up here real quick. We need to look up the particular value, 0.423. That's the conditional probability of seeing the word token you. And then we say, okay, cool. We got to take this value and we need to raise it to the second power because we had two u's in the text. So we need the probability of seeing one u times the probability of seeing another u. Multiply them together. That's u squared. And when you take 0.423655555 stuff times itself, what you get here is a score of 0.197 and some jazz after that. And then what you can do here is you go over and you can see the score. Once again, it's just a multiplication of all these things. And then we can go take a look at the spamness score of this. And once again, it's just a multiplication of all the things. And because this value is e to the negative 10th, it has more zeros after the decimal point than the spamness score. We then say, well, ham is the higher score, so we predict that this particular message is in fact ham. This is what's awesome about a naive Bayes classifier. It is super simple. Once you actually figure out what's going on, setting these things up in Excel, it's not a problem. So you can easily create naive Bayes classifiers in Excel with the data that you have to do the kinds of things that we just showed here. And it doesn't have to be spam filtering, by the way. It could be, should we approve this loan? Yes or no. Is this particular customer going to convert to paying? Yes or no. Or it could be something like predicting how good of a customer somebody's going to be. It could be a silver customer, a bronze customer, a gold customer, a platinum customer, right? It doesn't have to be only two labels. It could be any number of labels. Generally speaking, naive Bayes is typically used in a two-label or binary situation. Now, here's the only thing. Even though this particular classifier, this particular algorithm, this particular predictive model is very, very simple to set up and build in Excel, like with so many things in Excel, when you're doing data mining, eventually it just becomes untenable. Either Excel just runs out of steam because you can't put enough rows in it, or you have just so many columns that it just becomes unwieldy. So this works very, very well, relatively speaking, as long as you have a small data set, 100,000 rows, maybe 100 columns. But if you're looking at a real world type of problem in this like email, text, spam filtering space, you would have millions of rows of data and maybe tens of thousands of columns of data, right? Because for each individual type of word that exists anywhere in any row of data, you got to have a column for it. So this bag of words model means that you typically have lots of rows and lots of columns. And that's where Excel, quite frankly, breaks down. The good news is that you can use this, like I said, for small data sets, but if you need more power, if you want to use naive Bayes classification and you need more power, you just can't do it very easily in Excel, or maybe not at all in Excel, you can then graduate from Excel to R programming. I know what you're probably thinking, like, whoa, Dave, R program. No, man, that's why I'm watching this video. I don't program, I use Excel. I get it. It's totally cool. Just know this. Learning R programming is super, super easy if that's what you need to do to get your work done. And I don't expect you to believe me. Check out this video up here. I will show you in this video how easy it is for any Excel user to learn how to use R programming. And then you can use techniques like naive Bayes on much, much larger data sets than you can actually use in Excel. If you're interested in learning more about mining data with Excel, check out a couple more videos on my channel. I have a number of tutorials on how to do advanced analytics using trusty old Excel. Also, if you like this video, if you found it useful, If you wouldn't mind, you could help me out a lot by just giving me a like on this particular video. That'll just alert YouTube that this is quality content, and then it can be distributed to more people that might be interested in learning how to mine data using Excel. Okay, that's it. Naive Bayes classifier with trusty old Excel. Until next time, please stay healthy, and I wish you very happy data sleuthing.